Okay. Good afternoon, all of you. Uh, Previous link, the Tuesday link, already that link is will be active for every Tuesday classes. Okay, the link which has been sent in the earlier for Tuesday, same link will be active for Tuesday classes. So please share the link to others. Okay, as we if we uh, see in the numerical section, in numerical section in your Agarwal book, okay, in your Agarwal book, you can see in your Agarwal book you can see number of problem is there, number of problems are there, and problem regarding suppose in the last class we had one problem like the permissible speed of the railway track. After permissible speed of the railway track, there are lots of problems regarding your length of the transition curve. Then the what should be the speed or what should be the uh, super elevation on main line and what should be the super elevation in your branch line, that kind of problem which is directly related to negative super elevation or negative current. Okay, so for suppose already discussed what is negative super elevation. Already I have discussed what is negative super elevation, and if negative super elevation related problems are there, then you have to find out in numerical question what should be the negative super elevation for your branch line and what should be the speed of the vehicle on main line. Already you have seen the in your in the last class what is the negative super elevation, the figure of negative super elevation already you have seen. Negative super elevation pictorial view or the figure of negative super elevation already you have seen. This is your main line, this AB and CD is the main line, and this CF and AE is your branch line. Okay, if so this main line and branch line configuration, and the incident is the phenomena is the for this main line your A point should be higher than the C point because this is the curve of main line, and when your vehicle is passing through this main line we need one super elevation on outer track, that is AB. AB is the outer track of main line. So at point A, the super elevation should be higher, or raising portion of this at point should be higher than point C. But also in the same time, at the same time, in the branch line, when your vehicle is moving through this branch line, the branch line is AE and CF, AE track and CF track. During moving the vehicle on branch line, the C point or the outer track of the branch line should be higher than the AE track, or the should be this outer track should be higher than this inner track AE track. Therefore, C point should be, in that case, when your vehicle is moving through branch line, the C point should be higher than the A point. But when your vehicle moving through this main line, your A point should be higher than the C point. This is the contradictory condition in railway engineering. For that purpose, negative super elevation fundamental has been introduced in railway engineering. What is this negative super elevation? In a straight layman's theory, if I say the negative super elevation is that normally what we see that always the super elevation is provided on the outer track. Suppose if AE and CF is our branch line, so CF is outer track for this branch line, and the super elevation should be higher on this CF, or super elevation is provided on CF line. This CF line, on this CF line super elevation is provided. But in negative super elevation cases, this CF line or the elevation of the CF line should be lower than the AE line. Because if we don't follow this rule, then it is not possible to moving vehicle at through both this line at the same time, because we are providing super elevation at CF line, we are providing the super elevation AB line. It is not possible. So that's why what is we are followed, actually we are provided super elevation at the CF line, but this super elevation is negative or lower than AE value. Therefore, in that case, the elevation of AE line is higher and elevation of CF line is lower. And the elevation of AE line is same as elevation of AB line. Okay, elevation of AB line. This is the fundamental of negative super elevation. Now, if we see on any numerical problem regarding this negative super elevation, so we can see there is one numerical on your negative super elevation in Agarwal book. I think this book is available to you. So you can see the question is, a broad gauge branch line track takes off as a contraflexure through a 1 in 12 turnout. 1 in 12 turnout is the one type of turnout. That is your branch line is taking contraflexure from the main line, that is turnout. Okay, so 1 in 12 turnout is the type of turnout. The turnout chapter will come later, but this is one of the turnout. So a broad gauge branch line track takes off as a contraflexure through a 1 in 12 turnout from a main line track of a 3-degree curvature. So the degree of curvature for main track is 3 degree. Okay, but degree of curvature of the branch line is not given, but we can find out the degree of curvature for branch line. How? Because 1 in 12 turnout means that your line, your branch line is taking angle from the straight line is 4 degree. This is one rule which will come later, but to solve this problem, if in your question is mentioned that 1 in 12 turnout, that means 4 degree turnout, 4 degree from the straight line, 4 degree angle from the straight line. Okay, and the curvature, the degree of curve is 3 degree of the main line. Due to the turnout, the maximum permissible speed on the branch line is 30 km per hour. So the speed of the branch line, the speed of the vehicle, maximum permissible speed of vehicle on the branch line is given, that is 30 km per hour. Calculate the negative super elevation to be provided on branch line track and the maximum permissible speed on the main line track when it takes off from straight track. So now the two things are needed to calculate, that is, one is negative super elevation to be provided on the branch line track and the maximum permissible speed on the main line track. These two things are needed to calculate. So first the confusion is what should be the degree of curve. If degree of the curve is available to us, so we can easily calculate everything, because through degree of curve we can calculate the radius of the curve, because radius of the curve because r equals to 1750 by d. If d is available, we can calculate the r. So in that case, only mention that 1 in 12 turnout, that means 4 degree curve, sorry, 4 degree angle, 4 degree angle of the branch line. Okay, so 4 degrees one available as per as per the data already provided in turnout section, turnout chapter. If you can see, when we go to the turnout chapter, turnout one of the chapter in railway engineering, so turnout chapter, you can see the 1 in 12, that means 4 degree angle, 4 degree angle from the straight line, and the curvature or degree of curve of main line is given, that is 3 degree, but degree of curve for your branch line, degree d of the branch line is not given. Degree of curve or curvature for branch line is not given. You can find out from this notification, on this statement you can find out. So for branch line, if we see in the solution section, it is given clearly that for branch line track the degree of curve is 4 minus 3. Okay, formula is degree of branch line equals to degree of straight line, ds, that means your 4 degree, minus degree of main line, degree of branch line equals to degree of straight line, that is 1 in 12 turnout angle, already 4 degree given by the standard value. Okay, 1 in 12 turnout is 4 degree. This is a standard value. So ds minus dm equals to dt. This is the formula. ds minus dm equals to dt. So ds is 4, dm is 3. Therefore, the dt value is available to us. The dt value is 1 degree. So the curvature of the branch line or the degree of curve of the branch line is 1 degree. So when degree of the curve is available, easily we can calculate the radius of the curve. Formula is 1750 by d. 1750 by degree of the curve is, that is 1. So radius of the branch line curve is 1750 meter. Okay. When radius is available, then easily we can calculate the super elevation of the branch line. Okay, super elevation of the branch line formula is E equals to gv square by 127r. G is 1676 for branch line, G value, and V value. This is the speed of the branch line. The maximum permissible speed on the branch line is 30 km per hour. So 1676 into 30 square by 127. I don't know why they have put it 0, but you can see later by calculating. 127 into r. R value is our radius of curvature for branch line, 1750. So the super elevation for branch line is 6.8 millimeter. But super elevation, this is the actual super elevation of the branch line, but the actual super elevation not is applicable for the condition like your the branch line, main line, when both are on the same curve, okay, on the same level, on the same turnout section, these super elevation is we cannot provide it on the branch line section. For that case, now after rounding it off a higher multiple of 5, it is taken as 10 meter, 10 mm. So we can take 10 mm. Okay, they have taken 0 because to find out this unit in millimeter, that's why they have taken 1270. Okay, no problem. So your result is 6.8. You have taken round off value, that is 10 mm. Next, the value of negative superelevation for branch line track. So the value of negative superelevation for branch line track, the formula is, this is x, this small x value is your negative superelevation. Okay, this small x value is negative superelevation, and just you have calculated the actual superelevation for branch line, that is round off figure is 10 mm. So 10 mm, that is a e, small e, minus CD. CD is the Kahn deficiency, and Kahn's deficiency value in normal cases normally 75 mm. This is normally it is taken 75 mm. So 10 mm, the formula is x equals to e minus CD. So 10 mm minus normal Kahn deficiency value 75 mm, that is 65 mm. Acha, 10 minus 75, the value should be negative, minus 65. So 65 mm negative. Your negative super elevation is 65 mm. Okay, negative super elevation is 65 mm. Where it is provided? It is provided outer track. So instead of raising the outer track, we are decreasing the elevation on branch line. This is called negative super elevation. Okay. Now negative super elevation value is available for branch line, and which we will provide on the outer track. The super elevation to be provided on the main line track is 65 mm. So what is your value? What is your value for negative super elevation? Same value is being provided for the your super elevation of main line track. But if the negative super elevation or super elevation for branch line is negative, in case of main line, this value should be positive. Here you can see the 65 mm is the negative super elevation for your branch track. Okay, minus 65, outer track elevation is minus 65 mm, and the same time the super elevation for main branch or main track or outer track, super elevation for outer track for main branch is positive 65 mm. Okay, this is the actual fundamental of negative super elevation, which is the same as super elevation of the branch line track, but it is opposite direction. Same thing, 65 mm negative for branch line, 65 positive for main line. Okay, the maximum permissible speed is calculated by taking actual super elevation of the main line track, that is 65 mm. The 65 mm. Acha, our super elevation for main track positive 65. Okay, now have to calculate the permissible speed of the main branch or the main track. How can we calculate? With this only 65, if we have the super elevation, we can calculate the speed, but this is the game. What is adding it to the Kahn deficiency 75 mm and then using this value of super elevation. Okay, only this 65 is not the appropriate to find out the speed of speed on the main branch. With this 65, we have to add again 75, the Kahn deficiency value, and the value becomes 140 mm. 65 plus 75, that is 140 mm. Now you can calculate the speed of main branch. Okay, for requirement purpose, the main line track has a 3-degree curve. So the radius of the main branch of the line is the curve radius is 583.3 meter radius. Now the actual super elevation, to find out for the speed calculation, that is same as 1676 into v square by 127 into 583.3. this 583.3 value for this 140 mm super elevation, but actually you are providing 65. But to calculate your speed of on this track, you need to take this super elevation value, 140 super elevation value, which is coming 65 plus 75. So 127 and R value, which is coming for divided by 3 degree, because the 3 degree is the curve value or degree of curve for branch line. So GV square by 127 R is, what is the missing is the V, or this V value will come, that is 78.7 kilometer per hour for this 140 mm super elevation. But actually super elevation on the track is, which is provided, that is 65 mm, but the speed of the vehicle is 78.7 kilometer per hour, which is for 140 mm. Therefore obviously some current deficiency, creating some current deficiency, we are calculating the speed of the main track, speed or permissible speed on the main track, creating some current deficiency. Okay, my super elevation on the main line is 65, but I am taking, after adding this current deficiency 75 value, I am taking 140 and I am calculating the speed of the vehicle. This is the all about the negative super elevation. Okay, so first calculate the degree of the curve, of branch line, radius of the curve, equivalent super elevation for the branch line, negative super elevation for the branch line. After negative super elevation, fixed out the super elevation for main line. Now calculating after the actual super elevation of the branch line. Now to calculate the speed of the main line, add the current deficiency value with actual super elevation of the main line, and finally you can find out the velocity of the branch line. Okay, the permissible velocity on the branch line. This is the one important numerical for negative super elevation, which may come in your exam. After that we will go to your transition curve. Okay, transition curve. Next is our transition curve. Transition curve. This is one of the best picture to identify or to understand what is transition curve. As the writing part is not very clear, but we can understand. This picture I have taken from Khanna Jastu book, and this is also you have seen in your highway engineering. Actually this is one of the circular curve. Okay, this portion is circular curve. This portion is circular curve. This is your circular curve. This is your circular curve. Okay, now in this figure I'm telling all the part. This is circular part, this is circular part, this is straight part, this is straight part, this is circular part. So Actually this is our track, this is our railway track, and through this straight line my train or vehicle is coming, okay, through this track straight line, and suddenly the train has to be taken one turn, or he is facing one curve section or circular curve from straight portion to circular curve. He these the meeting point or this transition, how can we introduce this straight to circular portion on the road section, on the track section? That's why some portion has been added or some portion has been introduced between straight portion and circular portion, or straight line between straight line and circular curve. This portion is called transition curve. This element between the circular portion and the straight portion is called transition curve. Okay, because why this transition curve is needed, lots of things are involved to provided this transition curve between straight portion and the circular portion in your railway track as well as in your roadway, which is the necessary, which are the needs for introducing this transition curve between circular curve and straight portion of your track. In details, if we go in details, as soon as a train commences motion on a circular curve from a straight line track, it is subjected to a sudden centrifugal force, which not only causes discomfort to the passengers but also distorts the track alignment and affects the stability of the rolling stock. Rolling stock means the railway portion which is fixed, which is not movable. Some portion of the railway we can move. In suppose switching portion, we can move some portion in the railway track. Switch where switch is provided. Suppose rail is going some a single line and suddenly the rail has to be changed the another line. So at that case some switch is used, some switches are used in railway track. But which portion is completely fixed portion, that is called the rolling stock, and which is movable due to switch or due to electricity or due to mechanism or mechanical fitting, that is called movable section. So which is not only cause discomfort of the passenger but also distorts the track alignment and affects the stability of the rolling stock. In order to smoothen the shift from the straight line to the curve, transition curves are provided on either side of circular curve. Okay, both the sides you can see the transition curve is provided. Okay, both the side of circular curve, this transition curve is provided. So that the centrifugal force is built up gradually as the superelevation slowly runs out an uniform rate. A transition curve is therefore the curve for an uncomfortable ride in which the degree of curvature and the gain of superelevation are uniform throughout its length, straight from 0 at tangent point to the specified value at the circular curve. So infinity value of straight line to the tangent point, where this is the tangent point actually where our actual this transition length is starting. Okay, this is the tangent point where this is the tangent point where actually transition curve is starting, or meeting point of circular starting point of the transition curve, this tangent. Okay, already in circular curve the derivation of circular curve or elements of circular curve, you can see that's kind of figure where deflection angle is there. Okay, some tangent point is there, some intersection angle is there. So this tangent point is the starting point of transition curve. So from infinity point of straight line to this tangent point, normally these transition curves are provided on either side. Acha, okay, the build a transition curve is therefore the cure for an uncomfortable ride in which the degree of curvature and the gain of super elevation are uniform throughout the length, starting from 0 at the tangent point to the specified value at the circular curve. The following are the objectives of transition curve. So some objectives are there of transition curve. What are these objectives? To decrease the radius of curvature gradually in a planned way from infinity at the straight line to the specified value of the radius of a curvature, a circular curve, in order to help the vehicle negotiate the curve smoothly. Again, to decrease the radius of the curvature gradually in a planned way from infinity at the straight line to the specified value of the radius of a circular curve in order to help the vehicle negotiate the curve smoothly. Second, to provide a gradual increase of the super elevation starting from 0 at the straight line to the desired super elevation at the circular curve. Third, to ensure a gradual increase or decrease of centrifugal forces so as to enable the vehicles to negotiate a curve smoothly. Normally, to provide comfortable journey to passenger as well as to protect our vehicle, our train, our bogie, our engine, whatever, to protect from the distortion. Okay, to protect from distortion, and basically they provide the comfortable journey to the passengers. The transition car is provided on the track. Now these are the objectives. Next, requirements of an ideal transition curve. It should be tangential to the straight line of the track, that is, it should start from straight part of the track with zero curvature. Number 2, it should join the circular curve tangentially, that is, it should finally have the same curvature as that of the circular curve. Okay, it should join the circular curve tangentially, that is, it should finally have the same curvature as that of circular curve. Its curvature should increase at the same rate as the super elevation. Okay, its curvature should increase at the same rate as the super elevation. Okay, the length of the transition curve should be adequate to attain the final super elevation, which increases gradually at a specified rate. These are the requirements of ideal transition curve, and after these requirements, this is the actual transition curve. If we take some view of this portion. Okay, what can I say? The portion is magnify view of this portion, this joining portion. We can see the figure like that, transition curve. This is the transition curve, this is the angle phi. Okay, this is the straight portion. Okay, this is the P point, and this is the regular curve, or your circular curve is starting from this position. R is the radius value, and this is the types of transition curve. Lots of transition curves are there, many transition curves are there, like your spiral, Bernoulli's lemniscate. Also, this spiral also called the Euler spiral. This is the Bernoulli's lemniscate. This is the sine curve. This is the cubic parabola. And again, if we see this picture, same thing we can define or same thing we can introduce for all these cases, all these transition curve cases. And if we discuss each of these types, so first is Euler's spiral. Euler spiral, this is an ideal transition curve, but it is not preferred due to mathematical complications. And this is the equation. If this phi value and phi value should be L square by 2 RL. L is the length of the transition curve and R is the radius of the transition curve. Sorry, small l is the distance of any point on transition curve from the takeoff point. Small l is the distance of the distance of any point on the transition curve from the takeoff point. Takeoff point, actually up to the takeoff point, this L is taken, and capital L is the length of the transition curve. R is the radius of the transition curve. Phi is the this angle value. Okay, this angle value. Normally in our case we need this angle, if phi, or this angle phi. This phi value is actual the through this phi value we can define any transition curve. After that, this Euler spiral, this is there is cubical spiral. This is also good transition curve, but quite difficult to set on the field. So y small y equals to L square by 6 RL. Then Bernoulli's lemniscate in this curve, the radius decrease as the length increase, and this causes the radial acceleration to keep on falling. The fall is however not uniform beyond a 30-degree deflection angle. This curve is not used in on railway, so not necessary. Cubic parabola, Indian Railway mostly uses the cubic parabola for transition curve. The equation of cubic parabola is y equals to x cube by 6 RL. Okay, this x and y is coming from this figure. This x and y coming from this figure. Okay, and this figure is taking from this figure. Okay, this from magnifying, after magnifying this portion, we are getting this figure. This figure. This figure. Okay. So then after cubic parabola, another is S-shaped transition curve. S-shaped transition curve, in a S-shaped curve, and the curve and super elevation assume the shape of two quadratic parabolas instead of straight line ramp. An S-type parabola ramp is provided with this transition curve. The special feature of this curve is that the shift required, okay, shift would be explained. In this case is only half of the normal shift provided for straight line ramp. Normally S equals to L square by 48R. Okay, S equals to L square by 48R. Shift is required to understand S-shaped transition curve. So next our the topic is shift. What is shift? What is shift? For the main circular curve to fit in the transition curve, main circular curve to fit in the transition curve, which is laid in the shape of cubic parabola, it is required to be moved inward by a measure known as the shift. So actual this is the curve, okay, but properly fit in its position or properly fit with the track. This is actual our curve. This dotted portion is actual our curve, but this shift is very important. Okay, this shift is a very important term, and it could be asked anywhere in your viva as well as in your exams. Any exams you may ask what is you may be asked that what is shift. Shift is normally, this is the actual curve, the main circular curve. To fit in the transition curve, which is laid in the shape of cubic parabola, it is required to move inwards by measure known as the shift. Okay, the main circular curve to fit in the transition curve which is laid in the shape of cubic parabola, it is required to be moved inward by the measure known as shift. It is required to be moved inward by a measure. What is this measure? This measure is known as shift. Actual, this is our transition curve. Our transition curve which is sorry, actually this is our circular curve. Sorry, this is actually our circular curve. This is dotted portion. To fit in the transition curve, the laid in the shape of a cubic parabola, it is required to move inwards by a measure. This measure is called shift. And formula of the shift is S equals to L square by 24R. Okay, S equals to L square by 24R. This is important, one of the important formula. S equals to L square by 24R. Where S is the shift in meters, L is the length of the transition curve in meters, and R is the radius in meters. Okay, the offset, it should be in centimeter, from the straight line to any point on the transition curve is calculated using the equation. One equation is there, y equals to 16.7 into x cube by LR. You can find in your Agarwal book, where y is the offset from the straight line in the centimeter, x is the distance from the commencement of the curve in meters, L is the length of transition in meters, and R is the radius of curvature in meters. One formula is there, y equals to 16.7 x cube by LR. L is the length, R is the radius of the curvature. So that's formula you can find from your Agarwal book. Next is length of transition curve. Length of transition curve, we can find also length of transition curve. We have available the degree of curve, radius of curve. Now we can find the speed on the track from any from various formula. Now the thing is length of the transition curve. Okay, these the length of the transition curve prescribed on Indian Railway is maximum, and these are the formula to find out length of the transition curve. L equals to 0.008 CA into VM equals to CA equals to into VM by 125, or L equals to 0.008 CD into VM equals to CD into VM by 125, or L equals to 0.72 into CA. You know CA is the actual current, CD is the current deficiency. Again, where L is the length of the curve in meters, CA is the actual current in millimeters, CD is the current deficiency in millimeters. But what is VM? What is VM? VM is velocity. Obviously velocity on the main track. Wait, some equations I am showing. Just wait. Lots of formula is there. VM is the maximum permissible speed in kilometer per hour. Also in Agarwal book, page number 225, you can find the various lengths of transition curves to be considered when calculating speed. Okay, in the Agarwal book, you can find the various lengths of transition curves to be considered when calculating speed. And then after the length of transition curve, we have the vertical curves. Okay, vertical curves. an angle is formed at the point where two different gradients meet, forming a summit or sag. So suppose for these figures, for first two figures are there. For first figure, suppose this is the level already written. This is the level. This is the level. Okay, and the first is fall, then rise. First is fall, then rise. And that kind of situation is created. Rise, fall. Some apex is there in the figure. So this shape is called summit. Okay, maybe rise, less rise, fall, steeper fall, but all are summit. If some apex, upward apex is created, first rise then fall, this is called summit. And if first fall and then rise, final figure, in the final figure first fall and then rise, this kind of apex downward, this kind of shape is called sags. So summit and sags, both component of vertical curves, or two characteristics of vertical curves, summit curve or sags curve. By taking name this summit or sags, we can define the types of vertical curves or the shape of vertical curve, summit and sags. This is not important for your highway, not important for your railway engineering, also important for your survey engineering, surveying. Okay, this summit and sags curve in vertical curve section. So the angle formed and point of contact the gradient is smoothly by providing a curve called the vertical curve in the vertical plane. In the absence of vertical curve, vehicles are likely to have a rough run on the track. Beside this, a change in gradient may also cause bunching of vehicles in sags and variation in tension of coupling in the summits, resulting in train parting and the uncomfortable ride. To avoid these ill effects, the change in gradient is smoothened by providing a vertical curve. A rising gradient is normally considered positive and a falling gradient is considered negative. So in summit as well as in sags, rising gradient is positive, falling gradient is negative. During numerical, these things are needed to us. Rising should be positive, falling should be negative. Rising should be mentioned positive in percentage, falling should be mentioned in negative in percentage. Okay, maybe in summit, maybe in sags, that's no problem. Next is the calculating length of a vertical curve. There are also old method, new method, but we should follow the new method. So new method of calculating length of vertical curve, according to new method, the length of vertical curve is calculated by one formula, that is L equals to RQ. This formula also available in your book, that is L equals to RQ, where L is the length of the vertical curve, R is the radius of vertical curve. Till now we are discussing about our horizontal curve. Now this is vertical curve. So the radius, length, calculation of radius, calculation of length, all those things will be changed, and the calculation or some numerically how can we calculate, we'll see one problem. Q is the difference in the percentage of gradient. So three things has been mentioned under vertical curves. This figures is always this figures is summit, sags, the types of vertical curves, and one formula is there, that is L equals to RQ. L is the length of the curve, R is the radius of the curve, Q is the difference in percentage of gradients. The things will be clear from our one numerical. So you can see the numerical, just wait. Again I am coming to Agarwal book. This book, now this book is only available to us, so you should blindly follow this book. This book is good book. Blindly follow this book, and whatever the portion I am mentioning during class, that portion, that chapter, that topic, you should follow blindly, no problem. So under new method of calculating length of vertical curve, already I have told that the IL equals to RQ, this formula, and this one example is there. First you can see this example: a rising gradient of 1 in 100 meter, 1 in 100 meter, just wait, a rising gradient of 1 in 100 meter, 100 meets, sorry, 1 in 100 meter, not meter. A rising gradient 1 in 100 meets a falling gradient of 1 in 200. Okay, rising gradient is 1 in 100 and falling gradient is 1 in 200 on a group A route. The intersection point has a chainage. Intersection point has a chainage of 1000 meter and its RL is 100 meter. The RL of intersection point is 100 meter. Calculate the length of vertical curve and the RL and the chainage of the various points in order to set a vertical curve at this location. First you see this figure, this setting out a vertical curve. This is the intersection point which is telling in the question. This O point is the intersection point. This is our actual set out or setup of the vertical curve. This is smooth length of this vertical curve, the smooth length which is to be provided on the track. Okay, now as per question, rising gradient is 1 in 100, falling gradient is 1 in 200. Now our intersection chainage is 1000 meter and its RL is 100 meter. Calculate the length of the vertical curve and the RL and the chainage of the various points. So first gradient is 1 in 100 rising. So 1 by 100, that is 1%, and rising, that's why positive 1%. Second gradient, that is your falling gradient, 1 in 200 falling, 1 in 200, that is 0.5%, 0.5% falling. That falling means negative 0.5%. Now the difference in gradient, to find out the curve length, we need the difference, this gradient. The difference gradient, positive plus minus 0.5, that is 1 plus 0.5, 1.5%. It is difference in gradient. Length of vertical curve, formula is L equals to RQ. L is 400. L is 400. Actually this value is also standard value. The length of the vertical curve is normally 4000. Okay, length of the the R value, radius of vertical curve always 4000. Radius of vertical curve as per standard notification, that is standard value, this value is 4000. R value, radius of vertical curve 4000. This value is given in later you will see what the R value, 4000. 4000 into Q is this difference in gradient, that is 1.5 by 100, that is 60 meter. Length of the vertical curve is 60 meter. Now the chainage of point A in this figure, chainage at point A, our 30 meter chain. Okay, 30 meter chain, that's why first we have to subtract from the intersection point. Intersection point has chainage of 1000 meter. So from this intersection point we have to first minus, because A is the starting point, first minus 1000 minus 30, that is 970 meter. And at chainage point B, our intersection chainage is 1000, first minus then plus. So in second case we have to add this 30 with the at chainage B. So second time chainage point of point B 1000 plus 30, first minus then plus from the intersection chainage. From the intersection chainage first plus then minus. So chainage at point A 970 meter, chainage of point B 1030 meter. Then RL of point A 100 is the RL of intersection point, that is at 1000 meter chainage, that is 100 minus 30 by 100. Okay, 30 by 100, 31 in 100 into 30, that is 30 by 100. So our RL of point A is 99.70. Same thing, RL of point B 100 minus 30 1 into 100 or 30 by 200 into 30 or 30 by 200. So 100 minus 30 by 200 is 99.85 meter. Increase in RL for 60 meter, because length of the vertical is 60 meter. So increase in RL for 60 meter. Our starting point was 99.70 and ending point is 99.85. So increase in RL for 60 meter is 99.85 minus 99.70, that is 0.15 meter has been increased the RL value. Increase in RL for 10 meter, 0.15 into 10 by 60, that is 0.025 meter. First offset on vertical curve. Okay, offset is required to calculate. Formula is x into L minus x by 2r, where L equals to 60 meter, r equals to the radius of vertical curve 4000 meter from standard value, and x we are calculating for 10 meter, increase in RL for 10 meter. So 10 meter the offset on vertical curve. The calculation of RL of different points on the curve are shown in table. This is the table which is coming from this figure. You can see the RL point as well as the offset value at each point of this curve. Suppose chainage at 970, the point is A, RL of the point that is 99.7, offset after using this formula offset is 0, points on vertical curve A, RL points on curve 99.70. Again chainage at, we are taking the increase of RL for increase in RL for 10 meter. We are 10 meter distance. After 10 meter distance again we are taking, so point C value the 99.7000 plus 0.025, this value increase in RL and offset. So this is the complete calculation of the vertical curve. So you can see also from book, or you can also follow the book. In book also this problem is properly mentioned. You can take help from the book. Overall book is good for this stage. One book is there but no soft copy is available for that book, that is Saxena book. Okay, one of the good book. But for the time being you can follow this book. This book is good, and my suggestion is you should follow all the numericals, because in this class it is not possible to cover up all the numericals. Okay, so your task is you should follow all the numericals. You should solve in your home all the numericals, then it will be better for you, because numerical is important in railway section. Along theory, numerical also important, because numerical may come with theory. So thank you for this class. Just wait, I am taking attendance. Okay, thank you. Thank you. You can leave.